Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing functions and identifying features. This is standard A.3C in the great state of Texas, and we are using item number 33 of the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a graph of a linear function here. We do have all four quadrants, but it looks like it's quadrants 1 and 4 are a little bit more prominent here. So we simply need to find which statement is best supported by this graph. So let's open up our graph draw feature, expand it out. Let's increase the transparency all the way just so we don't see that grid on top of it, so we can draw all over this. So look at some of our answer choices. We need to identify slope, the x-intercept, the 0, and then we've got this y-intercept right here, kind of at the bottom of the screen. So let's define some of these, right? And then we'll see if we can identify them from this graph. So slope, that's what A is looking for. They say the graph is 1/2. So slope is your m. Remember, that's the change in y over the change in x. And if for some reason you forget that, that's the only part of this. If you look at your reference materials, you will actually find that slope of a line. Look at the very bottom of the screen. Everything else is looking for zeros and x-intercepts and y-intercepts. None of that is here. So none of that is going to be on this reference material except for that slope. So remember, this is our rise over run. Well, I can already tell you that A is incorrect without even calculating it. Now, if I wanted to, I can calculate this. Look, I've got 2 points right here, right? So let's just use these 2 points right here. So that's going to be an x of 0, y of 3, x of 6, y of 0. Let's make that x1, y1. Let's make that x2, y2. Let's go ahead and calculate that. But I'll tell you it's going to be wrong. I'll tell you how I knew before I even calculated it. And then that's going to be x2 of 0, and that's going to be x1 of 6, right? So it's going to be 3 over negative 6. Yeah, that's negative 1/2. Here's the thing. The 1/2 is fine. I knew this was a negative slope because it goes down from left to right. So if it goes down from left to right, it has to be negative. So that's why I knew A was wrong. The 1/2 is good, but a 1/2 slope would kind of look like something like this, right? It would be a little bit more like that. It has to go up. All right, so let's see what B has for us. The x-intercept of the graph is 6, okay? So the x-intercept is going to be where the line, or in this, that's the function, crosses the x-axis. So it intercepts the x-axis. That's why it's called the x-intercept. X-axis. Sometimes this writing tool doesn't always work. There we go. So where is it across the x-axis? Well, if I want to change it to blue there, looks like it's 6. The 6 is my x value, but normally we'll just use the x value as our x-intercept. So it looks like the x-intercept is 6. That looks good. So what's the 0, right? C and D should be incorrect. Well, the 0 is actually another name for our x-intercept. So it's really asking what happens if f of x equals 0, right? If f of x equals 0, what's that x value? Well, the f of x is measuring your range, and range is usually in most of our cases represented by y. So it's really saying if y is 0, like we've got right here, that 0 is going to be your x-intercept, that x value of the x-intercept. So no, our x-intercept is 6. So both B and C, the x-intercept and the 0, both referring to the same thing, just two different words for it. And then D is incorrect here. It's the y-intercept of the graph is 6. Nope, it's 3. So my answer is B.